Okay, so I'll do one more question for today, and so now we're still on the first exam of from 2015 fall semester, and we are working on question number 6. Sorry, my computer crashed uh for the last time, so I lost notes for this question. I'm sorry. And all right, let's get started. And it says which hydrogen transition represents the absorption of a photon in the visible spectrum? So this is a very time-consuming question if you encounter it in the exam, since you have to, if you don't have enough experience with Dr. Ma's question, you'll probably spend a lot of time to calculate all these energy transition states. I'll talk about the general way, and in order to save the time, I'll probably just talk about the general way, and we will probably just give you the answer. Since there's no like there's a shortcut, but it kind of consume your instincts. So like you have to have a gut feeling of like, I guess the answer is, you know, and so if you remember from your formula sheet, which again your formula sheet, your almighty formula sheet, uh, uh, there's a formula that says that 1/λ equals the absorption RH, which is a constant, times 1/n 1 square minus 1/n2 square. And then if we make some math manipulation, we will get like something like this. And the constant equals to RH equals to 1.97 times 10 to the 7, the power of 7 meters, 1/meters, and that's a constant on your formula sheet. And so lambda equals 1 1 1/n 1 square minus 1/n2 square. Yeah, and it has to be in the visible spectrum. So if you, I guess Dr. Ma talked about this during class times, that the visible spectrum is spectrums at between 400 nanometers to 700 nanometers, and that's on this side this is red, and on this side this is purple. Is that how spelled purple? Purple. Yeah, I think so. And with a shorter wavelength, it has a higher energy, so it appears to be purple. And with a longer wavelength, it has lower energy, so it appears to be red. And that's what a human eye can capture from the all the electromagnetic waves, and which is called the visible spectrums. And we need to get the lambda into this range, and all you need to do is just plug in the numbers and calculate out like what is the answer, what should be the answer. And well, this one looks a little bit too short, so, and if we're lucky enough, I guess the answer is either well, this one is a little bit too small, and this one is a little bit too high, so I suppose the answer is somewhere between B and maybe D or A, I suppose. E looks a bit too large either. So I'll try to do the calculations. Yeah, I didn't prepare ahead this time, since it's a very tricky question, and I wasn't planning to talk about it. I was trying to throw it to some other kids to do, but I'm just being kind. So okay, so question number answer number D gets 365 nanometers, which is not in the range, and this has been rejected. And I would like to try. And I remember from Dr. Ma's lessons that he will pass out a trick for this question, that he will let you remember all the transition that's possibly going to happen, and observe a photon in the visible spectrum. So oh, and if you remember it correct, absorption means negative. Oh, minus. So you should be able to get a minus number from this lambda with your n1 and n2 over here. So this line will be n1 and this will be n2. Cool. And let's try a different number and see. I hope it's 4 to 7. Even 3 to 2 didn't really work. I don't know. It's getting fancier and fancier. Okay, cool. So the answer 2 gives us 670 nanometers. 680 actually. 68 nanometers, which is also not correct. And try a different number and see. Question number C gives us 241 nanometers, which is also not correct. So we only have 2 left. The answer's not E, right? It should be. Oh, it is E. This gives us a negative 609 nanometers, so this is the correct answer. It's in the range that we're given over here. So it should be absorbing the purplish light. I'm sorry, a reddish light, or maybe a yellowish. So this should be a yellow light. I'll paint it in yellow. It's a yellow light, and so the correct answer should be number E. E. And we'll end here for this question. And I'll probably do some more tomorrow.